Geometric modeling. Geometric modeling is a method of representing the shape of an object using mathematics and computer graphics. It is used in CAD to create points, lines, surfaces, curves, and solids. Wireframe modeling. Wireframe modeling represents a 3D object using only edges and vertices, lines, and points. It looks like a skeleton of the model. Features: simple and fast, no surface or volume, difficult to interpret visually. Hidden lines are not automatically removed, used in early CAD systems. Wireframe entities. Basic geometric elements used in wireframe models: point, line, arc, circle, polyline, spline, curve, elliptical arcs. These elements combine to form the overall shape. Interpolation of curves. Interpolation means the curve passes exactly through the given data points. Example: if given points P1, P2, P3, P4, the interpolated curve touches all these points. Used when accuracy at each point is important. Approximation of curves. Approximation means the curve does not necessarily pass through the given points, but it stays close to them and maintains smoothness. Example: Bezier and B-spline curves approximate control points. Used for smooth, flexible curves. Parametric representation of curves. A curve is represented using a parameter, usually t. Example: x equals to f of t, y is equal to g of t, z is equal to h of t. Features: smooth mathematical control, easy for computer processing, can describe complex shapes. Used in Bezier spline curves. Non-parametric representation of curves. Curve is defined directly by x and y without parameters. Example: y is equal to f of x. Limitations cannot represent loops or vertical lines. Less flexible for CAD models. Curve fitting techniques. Curve fitting means generating a smooth curve from a given set of data points. Two types. Interpolation. Curve passes through all points. Approximation. Curve is smooth but may not pass through all points. Techniques include linear fitting, polynomial fitting, least square method, cubic spline, Bezier curves. B-spline curves. We will explain cubic spline, Bezier curves, B-spline curves. Cubic spline definition. A cubic spline is a piecewise cubic polynomial curve where each segment is a cubic equation. Curve passes through all given points. Interpolation. Slopes and curvatures are continuous at joining points. Very smooth and stable. Used widely in CAD for smooth engineering shapes. Bezier curve definition. A Bezier curve is a parametric curve defined by a set of control points. The curve starts at the first point and ends at the last point. Intermediate points act as pulling handles based on Bernstein polynomials. Smooth, flexible, widely used in graphics and CAD. Does not pass through all control points. Approximation curve. B-spline curve definition. A B-spline, basis spline, is a generalized spline curve defined by control points, knot vector, basis function. Features: local control. Changing one control point affects only a part of the curve. High flexibility. Smoothness guaranteed. Does not pass through all control points. Used in automotive and aerospace modeling.